Right, well, now for something completely different. Or not. Open science. And we will, as time has progressed, Tim has developed from not only providing countless useful tools for layer-fMRI analysis, but to a kind of crusade to make open science a reality. And this is also reflected in the second half of his thesis, and we have a really nice collection of speakers for the second session today, and it's a pleasure to welcome someone else who also bridges open science and layer-fMRI in many ways, and that's Pierre Bazin, who is now in Amsterdam, was previously in Leipzig. Right? Okay, thank you. The floor is yours.
All right. Thank you very much. Thank you for the invitation. So after all these very elaborate talks, I will go very, very light on some, maybe more of an experience on open science and how it can be a lot more, less straightforward than you would expect. So it starts, of course, with high-resolution MRI, 7 Tesla and above. What we have is beautiful contrasts. Now we can really push anatomical resolution, bring quantitative measurements, and do fancy things like looking at intracortical contrasts. So those are great promises, but there's also great challenges, and those are, well, increased anatomical resolution, quantitative contrasts, and the fact that we want to see intracortical contrasts in those images. So basically what we have here is very, very advanced MRI. And when I started the Max Planck back in 2011, none of the processing tools worked. So we could get those images, look at them, and sigh. So that's where I started working quite extensively in building a toolbox for this kind of purpose, so-called the CBSTools, specifically to go through all the steps to do what people do normally with things like FreeSurfer or SPM or FSL, just getting the images into structures, labels that you want to use, go into cortical laminations, measure depth, and so on. So in detail, so it's a toolbox that has been designed specifically for 7 Tesla data, so thinking about high resolution data, high numbers of voxels, working in spaces like 0.4 millimeter isotropic without spending weeks, and then looking at quantitative contrasts, which are something that you wouldn't see typically. Well, it's changing a little now, but that you wouldn't have seen typically at 3 Tesla or below. And then building tools that are related to the 7 Tesla applications, such as layering, cortical profiling, and co-registration of surfaces with high accuracy. And so at the time, I thought I had a pretty good system, building the software on top of existing open software. So what I did is I took the NIH-developed software called MIPAV, which has a very nice user interface, lots of formats that are supported, and the GIST system, which provides on top of that some pipelining information, and then added a special set of tools to go with. So that way there's shared development with a lot of different groups. Everything is open source and available, and there's a lot of resources that I could pull and getting that like this. And then there was also tools from different labs that would also have the same system, so you could get a very nice ecosystem. So at that point I was very happy and stayed happy about this for a while, thinking, well, maybe it is a perfect solution. But no. Unfortunately, people are lazy, me included. So one thing that is very difficult is to install software that depends upon other software that depends upon other software. And that then became a major hurdle. Also, with that software tools, you could encapsulate other tools, which is great. So you can just increase your ecosystem. But it's not that easy, so you need someone with specialized knowledge to do that. And the third part, which I found very amusing, was, well, it's using Java. Java was really all the rage maybe 15, 20 years ago. And now it's just the worst language you can think of for everything. It's still efficient, cross-platform, but it's really not popular, and people just don't like it. So at that point, I had a very interesting experience. I got a lot of free advice from various people. Some people told me, well, you should really create a SPM toolbox. Other people told me, well, you should just do a standalone set of scripts that work with FSL. Others say, well, you should just do something that works with a GIFT format, and then we can put it on the HCP workbench. And other people saying, well, you just wrap your gist modules into Python and then put them in NiPipe. So basically, everybody was telling me the same thing. Can you please make your software available in our favorite set of tools? And so that's, in the end, what I ended up doing. And nowadays, the way to do it is to go towards Python, which, well, is highly popular. So because it's popular now, all the cool neuroscience tools are there, and there's a lot of online community. And that's actually a big difference, because now I have some problems and bugs in the way I've run my program, and then I get an email from someone from a different lab who says, hey, I found a bug there, here's the fix that I made, can you just have a look, and then you can check on it and be happy with it. So that is very different from, hey, I can't install everything, please help. And to get there, I couldn't do that on my own because I'm an old guy who does Java programming. Nobody knows what it is anymore. So I needed to enlist the help of some very skillful neuroscientists who happen to be also Python wizards, Julia Untenberg in particular, and also Christopher Steele. And I took also opportunity of open science and open software initiatives, such as BrainHack and Google Summer of Code, who gave us a little bit of free space and free time to just drop everything else we were doing and focus on the code, focus on getting things figured out. And the first step of that we did during a BrainHack session was to figure out some Python wrappers for Java that would work without using a different type of Python that would not be compatible with the original Python. The nice thing with that is then you have continuity in the code and everything. And then with that, Julia really just took 3 months off with a Google Summer of Code and then just went through and added all the features to make it available on GitHub with a documentation that is automatically generated, adding with other people's help, automatic testing, Docker containerization, all sorts of bells and whistles, and all these things that we really want in the software from the user side. And of course, at the end, of course, a cool logo, because we need one. So this is kind of the state we are at now. We have a fully functional Python package behind the scene. There's Java, but you don't have to know about it. It's okay. And the nice thing is now you can interface that with NiPipe, with NiLearn, with anything that starts with Ni and has Python in it, and things that also don't have Python in them. I heard it's possible. So that's about it. I just wanted to share a little bit that story that making open tools is not just enough. Just bringing your code, putting it there, is not going to go necessarily very far, because there's a lot of things that come in the way, things you think were useful, like user interfaces. They can be actually cumbersome. competing tools. They actually want to work with you and compete with you at the same time. But so if you don't let them do that, then you cannot really compare. And the last thing I found was very puzzling, but it's interesting to think about, is that you really have to follow fashion, because the fashion comes with online communities, with infrastructure in software. And so right now, of course, the fashion is Python, and it's all cool for people who started with there and feel like, well, of course, that's the only way. But maybe in 10 years, it will be Julia or Ruby or whatever. And then we will have to think about how we translate our tools to make them still relevant many years after they've been started and developed. And with that, I thank you for your attention.
So we've seen fashion is important not only in dress but also in software. Questions? No questions? Bob.
Would you say that user interfaces are today's most perfect exemplification of the old expression of Procrustean bed?
I don't know that expression very well. You detail it.
Procrustean was a mythical person who used to torture his captives, but he had a bed of a particular length, and if his captive didn't fit on the bed, he cut off their feet or head.
Yep. Yeah. We do have that not only with so user interfaces have been that way. At some point, the web to the internet 2.0 has been also very strong at imposing very specific look and feel, and everybody has to do it. And now there's all sorts of problems also with different kind of standardizations as well, which are interesting. But if you want all your data sets to work with the HTTP Workbench, which is a beautiful tool, you have to go through the HTTP systems, the HTTP pre-processing pipelines, the HTTP tools. And so you are also stuck within that microcosm. And if your data is very different, especially at 7T, we see that all the time, every new data set is different, then those very standard approaches become sometimes a bit more cumbersome than they're actually helpful. And so it's a balancing act to try to maintain both, I think, because they're both valuable.
Great. The first comment. Yeah, so how does it work if somebody wants to contribute to your code now? Do they do it in Python then, or?
They go on GitHub and do a pull request. That's the stuff that people do now.
So there's Python.
There's Python and there's Java code. So if they want to code in Java, they can. But a lot of the things are now, everything is in Python, and then called some Java for things that require computation, because Python is not really good for that in itself.
Okay. Last, no, not the last. Well, we have various questioners all wanting to ask.
People are warming up.
Tom, you're it. Yes.
So I think it's really interesting to bring up this concept of fashion. And then so I kind of, as a non-Python user myself, I'd like to know, like, how robust are you to the inevitable Python going out of fashion? Like,
well,
what will you do, and like how do you see this tool in like a future incarnation when people don't like Python anymore?
So the nice thing is now I've been working through the process of building wrappers on top of something that is already antiquated and out of fashion. So I can do that a different time, and it's not a problem, hopefully. And hopefully now that there's a big Python community that will be crying because they're not cool anymore, they will try to build bridges to automatically bring Python code back into whatever's a new thing in fashion at the time.
You end up with like a sort of gobstopper model then, where it's like layer.
Yep. Yeah, it becomes a bit of an onion. But you can, of course, so you can do wrapper upon wrapper upon wrapper. I mean, I did try to do gist So take the gist modules that are wrappers around my code, and then wrap them into NiPipe so that they can be pipelines inside of pipelines with 3 different language programs. So that works. It's just silly.
So then how does that relate then to the initial problem you had, which is that people don't like things that depend on other things that depend on other things? Because it seems like that's basically an inevitable consequence of this kind of approach, right?
Yeah, so one of the nice things is when you go through that process, you have to lean down whatever your core code is. So right now my Java code is portable to pretty much any kind of wrappers. And I would basically take our wrapper and not wrap it around the Python, but around the Java itself directly. Because that is not going to change, and it's very simplified because it had to go through that process once.
If we can have a very quick question from
and also the follow-up. So, say you were designing everything from scratch, then you would still go with Java and whatever the most popular scripting language around, just wrap it.
No, right now I've heard Julia is the new thing for doing like real computations. So I would look into that.
So in implementing everything from scratch with Julia. So
yeah.
Not as a wrapper.
Why not?
Okay, that's a very concrete answer. So thanks once again for a really nice talk.